on 6.2. Number 6 was causing several people some issues. So if we come out x, that's what that x is supposed to mean on that one. So this would be the x-axis then. And do a slice perpendicular to that axis, which would look, as they drew it in there, something like that. They didn't label these axes, so I'm going to call this maybe Z and Y axis. So the sides, the sizes of these sides, this will be something in the Z direction. This side would be something in the Y direction. This slice would have a thickness that's in the X direction, so I'd say it's dx thick. And therefore I would be doing the integral in the dx direction from 0 to 8, but the area of the triangle would be 1/2 base times height. Well, clearly I need to replace the y with something that has x in it and z with something that has x in it. And that's where I need to use similar triangles. And I'm going to look at, let's do the y first. I'm going to look at this right triangle. This is a right angle in there. And this one. Now I'm interested in the y, so I'm going to start with y. And I'm going to say y is to, see that's this way on this one, to the big one, that would be 4 as, and I don't want to mess around with the hypotenuse, so I'm going to work with this one because it has x in it, but this one's not x, this is x. Whole thing is 8, this piece is x, so this piece is 8 minus x. So y is to 4 as 8 minus x is to the whole length x. And now if I multiply both sides by 4, I'd have an expression for y in terms of x. This would be 32 over x minus 4x divided by, oh excuse me, this shouldn't be x, this should be 8. Sorry, 8 minus x is to the whole length, which is 8, not x. My bad, that was bad. So this would be 4 times 8 divided by 8, which is just 4. Minus, and 4 times x is 4 divided by 8, which should be 1/2 x. There we go. Now I need to replace the z also, so it's going to be z is to 6 as 8 minus x is to 8. So this to this as this is to this. So I'm looking at this triangle and this triangle. Short leg to short leg of the bigger one is the long leg to the long leg of the bigger one. Multiplying both sides by 6, and this would be 1 minus 8x, so this would be z equals 6 times 8, 48 divided by 8 is 6, minus 6x over 8, and 6 over 8 is 3/4 x. So now this integral that we had up here becomes 1/2 integral from 0 to 8. Y is 4 minus 1/2 x, and z is 6 minus 3 force x dx. Now I have an integral that I can do because it's all in x with x. Now if I multiply this out, I would get 1/2 integral from 0 to 8. 4 times 6 is 24. 4 times negative 3/4 is negative 3x. Negative 1/2 times 6 is negative 3x. And this would be positive 3/8 x squared. So one more step of simplifying here. So I got 1/2 integral from 0 to 8 of 24 minus 6x plus 3/8 x squared. Now I can integrate that. That would be 1/2. And now it's going to be 24x minus 3x squared, because add 1 and divide by 2. Add 1 would make it 3 and divide by 3, so I'm going to get plus 1/8 x to the third. Evaluated from 0 to 8. The 0 is not going to produce anything, so I'm just going to get the 3 terms with 8 in here. So half of 8 is 4 times 24 is 96. 8 squared is 64. Half of that is 32 times 3, which is minus 96. And 8 cubed divided by 8 is 8 squared, 64, and half of 64 is 32. And so this comes out to be 32 cubic units. All right, now I'm going to do number, I believe 18 it was. No, yeah, 18, the tetrahedron problem again. I'm going to do it a little differently than I did last time. So, again, a tetrahedron has equilateral triangles for all sides of this pyramid. And so that's the equilateral triangle in the back there, and the base is an equilateral triangle. Now, in an equilateral triangle, a triangle, if the side was x, then if I drew the altitude to try to get the area, this would be x over 2. And using the Pythagorean theorem, this becomes the square root of 3x over 2. So the area of an equilateral triangle is half the base times the height, which is, or square root of 3 divided by 4 times the side squared. Okay, so that's the formula for the area of an equilateral triangle. And they told you in this one that if you make the height of this thing, the height is actually square root of 2/3 x, or whatever the side is. Now they said the side was s, so it'd be 2/3 s for the total height. And you could get that if you want. If this is s, this would be s over 2, just like if this was x, this would be x over 2. And the altitude would hit that point underneath the top, and it hits it at 1/3 of the way. So if this is square root of 3s over 2, the whole length, 1/3 of that, this length here would be the square root of 3s over 6, using Pythagorean theorem, and this length being the square root of 3s over 2, and that you can figure out that height has to be this. But that's not important for doing this one, because we're going to look at something else here. They said do a cross section of this, a horizontal slice. So if I make this direction, let's say y, and I'm going to make this thickness then dy. So I want to integrate the area of this triangle starting when y is 0 until we get to the top, which is the square root of 2/3 times the length of the side. Now, I'm not putting in an x-axis here. What I need to know is how long this side is as we go from y equals 0 and move to the top. The side will decrease and go to 0. So this is the tricky part on this one. We have to come up with a relationship for, if I'm up here some distance y, what is the area of this triangle? More importantly, what is the length of a single side, which I'm going to call x, just to match this formula here. So I realize that when y is 0, my x, when I'm clear down here at the bottom, and y is 0, the x will be the full length s. And as I go up in y, the s will decrease, or the x will decrease to 0. So when I get to y being square root of 2/3 s, when y goes from 0 to square root of 2/3 s, goes from the bottom to the top, x, or the side, is going to go from s down to 0. And more importantly, x is, as each unit I go up in the y, this is going to go a same amount shorter. So this is a linear relationship. So I should be able to write a term, an equation, if this is my x, this length of the side, and y is the height I am up. I should be able to write an equation for how x and y relate. So my slope would be change in y, which goes from 0 to that, so that's square root of 2/3 s, divided by the change in x, goes from s to 0, so that's negative s. That's my slope, and the s's cancel. So if I were to write the equation, it's going to be y equals, these cancel, and it's just negative square root of 2/3, and then it's going to be times x plus something that makes the y-intercept, but this would be the y-intercept, so plus the square root of 2/3 s. So that's how y and x relate. If I move up some in y, this will tell me how long the side of this is. Now what I want to do is integrate in terms of dy, the area of this triangle, which is going to be square root of 3/4 x². Well, since this is y, I need this to be y, so I have to solve for x in this. So I'm going to do that, subtract this from both sides, so I'm going to have y minus the square root of 2/3 s equals negative square root of 2 over 3x. I'm going to multiply both sides by the reciprocal, which would be negative square root of 3 over 2. Negative square root of 3 over 2. So I'm going to get negative square root of 3 over 2y, and a minus will be plus, and square root of 3 over square root of 3 cancels, square root of 2 over square root of 2 cancels, plus s is what x is equal to. So I'm going to put that in here for x and square it. So this becomes the integral. I'm going to take the square root of 3 over 4 out of here. That came from the area formula. X squared is going to be this squared. dy. And that would be from 0 to square root of 2/3 s. Now, I want to integrate this, so I'm going to do a U-substitution. So I'm going to come down here and say, I'm going to let U equal all this mess, which is going to be negative square root of 3 over 2y plus s. du is going to equal just negative square root of 3 over 2 dy. So dy will be replaced with, multiply both by the reciprocal, the square root of 2 over 3 negative du. So I'm going to go back to this integral here, and I'm going to make it the integral. And if I put 0 in here, I'm going to change my limits. I've got the square root of 3 over 4. 0 into here would be u would equal s. And if I put square root of 2 over 3 in here times square root of 3 over 2, that's just negative 1 plus s. Square root of 2 over 3 times negative square root of 3 over 2 is just 1 times negative is negative 1 plus s. And this would now be, all of this would be u squared, and dy is going to be this times du times negative square root of 2 over 3, so I'm going to put that out here, negative square root of 2 over 3. The square roots of 3 cancel, and I get the square root of 2 over square root of 2 over 4. 4 is not in the square root, the 2 is, so that's negative square root of 2 over 4, and the integral of u squared is 1/3 u to the third. And I'm going to evaluate that from s to minus 1 plus s. And that would equal, let's see here, so that's negative square root of 2 over 12. And that would be minus 1 plus s is the same as s minus 1 cubed minus s cubed. And my s minus 1 cubed is it seems to me that I should have something different here. Okay. What? No. Let me take a quick look at my notes. Oh. This is, I'm putting in, I've made a mistake here on my limit. I thought something was strange here. When I put this into here, I get minus 1 times this times an s. So I got minus s plus s, which is 0. There we go. That's limit should be 0. So I'm putting in 0. Yes, this should be 0. If I put this in here, I get this times that, which is minus 1, times an s. So I get minus s plus s, which is 0, 0, 0. So now this is going to work. So that cubed is gone, and so I got minus a minus, which is plus this s cubed. There's the answer. Now in the back of the book, they multiply the numerator and denominator by the square root of 2, and they end up with that 2, they end up there, and 12 square root of 2. The 2 goes into 12 and makes 6, so they get s cubed over 6 square roots of 2. Actually, they don't have in the back of the book, but that's a typical formula for the volume of the tetrahedron. Okay. It's easy to make a mistake. Good thing I have my notes on that, because I would have not caught that right away. All right. Now let's do 30. Now 30 is a much simpler problem. It's just talking about gorillas in an area around a lake in a grassy area. And it has a formula for the radial density of the gorillas. It says that the number of gorillas, the radial density of the gorillas is 52 1 plus r squared to the minus 2. So what this is, and this is gorillas, number of gorillas per square kilometer. So to get the number of gorillas, we're going to have to multiply this by an area. Now let's see how that works. Now what this is doing, and it's like any population that's centered around something like a city, as you move further and further out, the population gets less concentrated, less dense, less number of gorillas per square kilometer. And this formula is supposed to tell us how many gorillas are on a square kilometer at some radius, and if you go a further radius, it'll reduce. So the idea is that the density should be all the same at some equal distance out here. And we want to find out all the gorillas on that ring, and then on the closer ring, and then on a closer ring, and work our all the way in, or vice versa, all the way out. So we want to add up the population from the center at radius 0 all the way out to, how far out? Where's the problem? Let's see here, to 5 kilometers, I believe. Yes, out to 5 kilometers. So we're going to do consecutive rings here, figure out the area of a ring. Well, the ring has a width of dr and a length of 2 pi r. So those multiplied would be an area times the formula for how many gorillas are on a piece of that area. That would be times rho r, and that's going to be 52 times 1 plus r squared to the negative 2. Okay, now the 52 can come out with pi r, and we're going to do a substitution for 1 plus r squared, because that'll produce an 2r in the denominator, and we'll be able to simplify that r. So I'm going to do that u substitution. I'm going to let u equal 1 plus r squared. Du would be equal to r dr, and du divided by 2r is going to be what I replace dr with. So this becomes the integral from 0 to 5 kilometers to 52 times 2 pi times r u to the negative 2 dr, which is du over 2r. The r's cancel, and now I have a simple integral. I can take the 2 out because it's times all this, and that will cancel a 2, and so I'm going to have 52 pi. The integral of u to the negative 2 is negative u to the negative 1. And I'm going to evaluate that from, now I'm in u, so I shouldn't have had 0 and 5 in here. 0 squared is 0 plus 1 is 1. And 5 squared is 25 plus 1 is 26. So I'm going to do this from 1 to 26. And this is the same as negative 1 over u. So I'm going to have 52 pi times negative 1 over 26 minus a minus, which is plus 1 over 1, which is 1. So 52 pi times this, 26 goes in there 2 times, and it'd be negative 2 pi plus 52 pi, which turns out to be 50 times pi, number of gorillas. Okay?